So let me introduce the team. The last author I like to call Yoda because he's been the brainchild of this fairly large-scale project where we're trying to do several stages of study on lake trout morphological diversification. You can think about this as in the development of new species, you start somewhere with an organism diversifying within a single place and then figuring out how to be reproductively isolated. So the life history side of this is myself and Nancy Nate. Andrew Muir has sort of inherited the reins of the project, and Chuck Bronte needs no introduction. I suspect Chuck has forgotten more about lake trout than most of us will ever know. And then Mara Zimmerman was the original postdoc on the project. So basically the rationale here is fairly simple. Morphological diversity of lake trout was at one time, at least in Lake Superior and some of the other big lakes, was quite extensive, but when stocks collapsed, a lot of that diversity was probably lost. So there were many forms in shallow and deep water, and they were present in such obvious numbers and diversity that many of the historical records that described lake trout in places like Lake Superior, there were just scores of descriptions of very obviously different lake trout. So as we all know, fishery exploitation and sea lamp predation probably has left us with just a vestige of what was once there. And the question we've wanted to ask was, can this historical morphological diversity of lake trout stocks be restored? And then what would it look like? So that leads to some recent studies. This is an illustration from Andrew Muir's recent paper that went to Isle Royale and described the three fairly well-known forms of lake trout. The top fish here is a lean. The second one down is a humper. The Siskoet or fat trout is the third fish down. And then a new form called the redfin. Redfins were described historically, but only more recently now described by Andrew as a distinct morphological variant. So the point is that these morphs also occur elsewhere in North America, and that's been a part of the project that Chuck has led to go explore these other water bodies. Basically, these lakes tend to be very large, bathymetrically complex, and that means they're usually deep. Depth affords lake trout a chance to diversify morphologically. So this diversity in other lakes then we think might be useful for informing us about where we can go in the future with recovery of this diverse species into other Great Lakes. We think the life history traits in these other lakes might be useful for informing our expectations for recovery. So these are some of the places we've gone to. In the upper left cluster is Great Bear Lake, and across from it Great Slave Lake. These are two of the non-Laurentian North American Great Lakes. And then we have in Lake Superior this cluster of four morphs. There's a small lake tucked just on the south shore of Lake Superior called Rush Lake that was probably once connected to Lake Superior and now has a humper form in it. And then Lake Mistassini, the largest lake in Quebec, also has a humper form. So this is the broad landscape that is part of this project. Our hypothesis here is that life history traits of lake trout morphs will differ among those morphs. That sentence got obviously quite disturbed. So our project is to compare life history traits among morphs of lake trout within lakes and then among lakes. So the idea here is to take a location such as Isle Royale and check the diversity of forms to see if their life history traits differ, and then look more broadly across different water bodies and places. So our project here that I'll describe in a moment is looking at some standard metrics like size, structure, body condition, buoyancy, survival, growth, and maturity. And coming back to this lake then, today's presentation isn't about Great Bear Lake, but it is rather about Lake Superior. So we'll zoom in here and talk about this particular lake. So today's presentation is going to be about Isle Royale, but we also have collections from other places in Lake Superior shown here, like Superior Shoal, Standard Rock, Big Reef, Grand Marais, and Klondike Reef. And our objective in the next phase is to compare the morphological traits of these same morphs, but in different locations, to see whether those traits are consistent. So on to Lake Isle Royale. Nets were set in various locations around the lake and in various depths, generally trying to target a relatively good distribution of netting effort within these three depth strata, 0 to 50, 50 to 100, and 100 to 150 meters. You can see the number of sets in each of those depth strata. The sample processing is basically a standardized sequence of events. The fish surrender everything they know, which is a photograph for a whole body photograph in a very stylized way to allow morph assignment using statistical methods. These have been fairly well described elsewhere. The fish are measured in length, air and water weight, sex, and maturity state. The air and water weights are used to index buoyancy. And then we collect otoliths for age and growth history, for working on growth, maturity, and so forth. So these are the four morphs from our paper that is just coming out now in JGLR in the April issue. This is the distribution of numbers of fish. I've put in the number of adderite morphs because that's something interesting to some lake trout people. These fish are all scaled to the asymptotic length of each of the morphs to give you a sense of their relative sizes. You can see the humper is the most obviously shortest of the bunch. The others are relatively similar lengths, but they have very different shapes, and those morph assignments then were based on a statistical and visual examination of a whole lot of fish. So I'm going to go into, I can totally skip the methods here so you can't pin me down on the details. First of all, their depth distribution. There's going to be a series of graphs that are very much like this. The y-axis will change on each graph. The x-axis will be the same. So the morphs are arranged on the x-axis as lean, humper, redfin, and ciscoette. The left panel shows you the metric on the y-axis in the three depth bins, and then on the right panel, the mean value along with the comparison of those mean values. So the point here is that the lean form in the left panel gets progressively less abundant as you go deeper. The other three actually peak in the middle depth bin. And those, the average catch per net or fish density is not significantly different for leans, humpers, and redfins, but the ciscoette is far more abundant. And the Lake Superior is a great ciscoette lake. It's probably a fairly marginal lean lake trout lake. And this is an illustration of that phenomenon. The next metric is just simply the average length. So you can see on the y-axis that the redfins are the largest bodied of the three morphs. There's also interesting patterns of changes in mean length with depth. So the smallest fish of three morphs, the lean, humper, and ciscoette, are in the deepest depth stratum. Overall, the leans and humpers were not significantly different than the redfins and ciscoettes. I'll come back, though, to talk about body size in a couple of different ways. The first is an index of body condition, where basically I assembled the residuals from the grand weight-length relationship and then tested whether they were different among morphs. So this is just a relative body condition index. The heaviest for standardized length, then, is what we're depicting here. You can see the trends with depth. The leans are the only ones that systematically change in body condition through depth. The others are displaying different patterns. But the point here is that the relative body condition or mass per unit length is greatest for ciscoettes and redfins, and less for the lean, as you'd expect from their names. Buoyancy is this measure where we combine the wet and air weights. And this is a similar statistical procedure where we take the relative buoyancy from the relationship between wet and air weights. You can see that the relative buoyancy tends to go up and is highest for each of the morphs in the deepest depth stratum. And that would make sense. Relative buoyancy is more important when you don't have a swim bladder that will function at these very deep depths. And then in this case, the leans are the lowest in buoyancy. The other three morphs are not significantly different, but the redfins appear to be the most buoyant. Now the mean age. This is one of the metrics you get from these otoliths. The mean age, the point here is that the leans are the youngest of the three morphs. The others are relatively older, and the redfins are the oldest of the bunch. Maturity, length at maturity first, and then I'll show you age at maturity next. So the maturity schedules are on the left panel. This is a change in the graph form. But on the right panel then, the leans have the longest length at 50% maturity. The other three are relatively similar and quite a bit shorter at maturity. Age at maturity, considerably better, less well-defined than length. The age at 50% maturity appears to be somewhat higher for leans and humpers than for the other three. Growth curves, the only point for me to show you this graph is that the humpers are the shortest body size. The graphs on the y-axis are all length in millimeters, and on the x-axis age in years. Importantly, if you are from one of the lower lakes, the x-axis goes out to 50 years. I noticed in previous meetings your lake trout are what I would call horribly young. So the humper is decidedly shorter at its asymptotic length than the other three forms. The other three are less different. So let's look at a couple of the key statistics. Asymptotic length, or the ultimate length as Castleman likes to call it, on the left axis, or the left panel, and then on the right panel, this is omega millimeters per year, the early growth rate. So the point here is that the leans are the fastest growing, faster growing than the other three morphs. The ultimate length isn't quite as clear. The humpers are quite a bit shorter, but Siskoets also have a shorter asymptotic length. So those are the traits of the four morphs, and so the traits that were basically used to assign these fish to morphs now seem to be exhibiting differences in life history traits. So where do we go next? Well, what we like to do next is to take this analysis to compare these morphs among the other sites that we have samples from. This is just a bar chart showing you the distribution of the four morphs. The bottom bar are the fish that we have yet to assign, because we had some recent collections in 2013 and 2014. You can see that the humper morph was predominant, or was most common at Isle Royale, as the lean was. The Siskoet morph, pretty common at Isle Royale also. And the redfin was the dominant morph out at Superior Shoal. So the next phase here will be to take this analysis to compare these morphs, their characteristics among these sites within Lake Superior. And then following that, take the same analysis to the rest of North America, which is represented here. Now the segments on the bars represent Great Bear Lake, Great Slave Lake, Mistassini, Superior, and Rush Lake. Rush Lake is that little lake just to the south of Lake Superior. The point here then is to see if these life history traits are consistent within morphs among lakes, or is the opposite true? So again, the point is that we think we can inform our expectations for recovery of this morphological diversity by looking broadly across North America, but also broadly within Lake Superior, and then perhaps transporting that knowledge to the other lakes. So a whole lot of people contributed to this work. This is a fairly large project where, like I said, the fish tells us everything it has, genetics, stable isotopes, a whole bunch of things that are carried out by lots and lots of people, and the collections across North America were by some of the people in this room, including yours truly. So with that, if there's time left, I'll take questions.